This is section 9.3. It's going to be the last section we do in this unit, and really it's similar to what we've been doing. It's just using a different notation, and this notation may be familiar to you from your physics class if you've already gone through physics. So notice the first line. It says if the sine of theta equals 1, and so what we did in 9.1 and 9.2 was we said, hey, think backwards, right? I can look at my chart and I know that theta, the angle when sine equals 1 would have to be pi over 2. But I want to talk notation. We would say that theta is called the inverse sine of 1. All right, so when you're going backwards, when you're finding an angle, we call it an inverse function. Now the notation that we use in trig, again, this is the notation I'm thinking you might be familiar with from physics, is we would say that the angle is called the arc sine, or this notation means the inverse sine. So arc sine, or this sine to the -1, both of those mean inverse. And I do want to point out, I know this looks like an exponent of -1, but it's not, because an exponent of -1 means 1 over, right? It means move it to the denominator, and that's not what inverse means. Inverse is not the same as reciprocal. I'm going to put that here. Inverse is not the same as reciprocal. So how do I know if when I see a -1 if it means inverse or if it sees reciprocal? Well, it's going to be the context of the problem. If it's written like this on a trig function, it's going to mean inverse, not reciprocal. So it'll never be difficult to know. All right, so the answer to an inverse trig function is always an angle measure. Why? Because you're going backwards, right? Because the inverse equals the angle. So for example, I would say the inverse sine of 1/2, so think backwards, what angle will the sine equal 1/2? Well, that's going to be an angle of pi over 6. And based on what we said in the last couple of units, since the sine is positive 1/2 in 2 quadrants, in the past we said, well, it's going to be pi over 6, or the second quadrant, which would be 5 pi over 6. Or we would say the inverse sine, or arc sine, of -1/2 is going to be, let's see, that would be the third and fourth quadrants, so 7 pi over 6 and 11 pi over 6. However, we're going to make a little change here. The trig function has to have a restricted domain in order to find an inverse trig function, which may or may not make sense. But basically what that means is we're not going to use both answers. We're only going to use one of the answers. And so I'll cross off the one that we're not going to use here in just a minute. So this means inverse trig values come from only 2 quadrants. So if you need it to be positive, you're going to use a particular quadrant. And if you need it to be negative, you're going to use only one particular quadrant. And so this is the way all textbooks will define inverse trig functions. So when we say that if you're thinking about the sine function, we're going to restrict it to be from negative pi over 2 to positive pi over 2. So hopefully if you think about negative pi over 2 would mean you're talking about the fourth quadrant. Positive pi over 2 would mean you're talking about the first quadrant. For cosine, notice it's only from 0 to pi. So hopefully that makes sense. We're only looking at the first and second quadrant. And then for tangent, the same as sine, you're going the fourth quadrant and then the first quadrant. So up here, what that means is when I say the sine, the inverse sine of 1/2, I only want the first quadrant, so I wouldn't include that. Or if I say the arc sine, or the inverse sine of -1/2, now, since the sine is restricted to first and fourth, then that means you're thinking, oh, it's 11 pi over 6. But notice how it's defined. 11 pi over 6 is not in that interval. So that means if you think about going in the negative direction, it would be negative pi over 6. And that's just how we define it when it's an inverse trig function. I could get way more involved and tell you why. It has to do with how the graph is defined and different things. But And we're just going to touch on the notation for purposes of this section. So it's actually much easier than it sounds from that description. So look down here. Number one, what's the arc cosine or the inverse cosine of 1/2? Well, at what angle, does cosine equal 1/2? Well, that would be pi over 3. So if it's positive, it's always the first quadrant. There's nothing to worry about. And there's only one answer when it's written in this notation as an inverse trig function. Or I could say the inverse sine or the arc sine of root 3 over 2 is going to be pi over 3, because that's the angle when sine is square root of 3 over 2. So inverse cosine or arc cosine of 1/2. Well, I know the reference angle for cosine to be 1/2 is pi over 3. Because I want it to be negative, remember cosine is defined in the first and second, so I would say 2 pi over 3. I don't say negative pi over 3 because that would be the fourth quadrant, and think about it, cosine is positive in the fourth quadrant. Okay, so number 4, arc tangent of -1. Well, I know the reference angle is pi over 4, so I want it to be negative, which means the tangent is defined in the first and fourth. So the fourth quadrant, we would say negative pi over 4. Okay, inverse sine of 1, well, I know the reference angle is pi over 2. Since I want it to be negative, instead of saying 3 pi over 2, think the fourth quadrant going in the negative direction, so we're going to say negative pi over 2. And when does tangent equal negative square root of 3? Well, I know the reference angle is pi over 3. Fourth quadrant, I would say negative pi over 3. Okay, so when it's written as an inverse trig function, we only give one answer. It's just a matter of deciding how we're going to give that answer, what quadrant. So what if it's not a unit circle value? Meaning, what if it's not one of those numbers that fits on the chart? Let's put here, not on chart. Well, can I still find the angle? Yeah, you can, but you're going to have to use your calculator. And we actually did this when we were solving the triangles way back in the first unit, I believe it was, or unit 6. So if it's the arc sine of 1/4, well, that's not on my unit circle. So how do I do that? Since I'm trying to find an angle, remember the answer is an angle, and so inverse is when you press your second. So it's going to be second sine of what? Of 1/4. So 1/4. And it's going to give you an answer as a decimal because this is my radian answer. So instead of saying pi over, they've converted pi to 3.14 blah, 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 and, you know, over whatever fraction it might be. And so the decimal answer is this. So let's give our answer, let's see, how should we round? Let's give our answer rounded to the third decimal place. So I'm going to say 0.253. 0.253. Or if I want to find the inverse cosine of 0.75, so second cosine 0.75, and that's going to be 0.723. 0.723. Okay, so that's just a brief introduction to inverse trig functions.